Hi, my name is Willa Potosnak. I'm a senior biomedical engineering student at Duquesne University. I'm also a research intern at the Auton Lab, which is part of Carnegie Mellon University's School of Computer Science. I will be talking about current research I'm working on in the lab titled Robust Rule Learning for Reliable and Interpretable Insight into Expertise Transfer Opportunities. Hospital intensive care is generally distributed to different intensive care units or ICUs. We hypothesize that clinical expertise can be shared between units to potentially improve outcomes for patients. Machine learning can be used to identify patients who could benefit from the expertise of an external unit. However, machine learning methods applied for this purpose must be reliable and interpretable to promote clinician trust in the identified patients. We focus on transferring expertise in the form of models that predict risk of healthcare outcomes for patients. The Federated Classifier Selection Algorithm, or FRECLES, generates decision lists with rules to identify patients for whom external unit models could be more competent at predicting healthcare outcomes. Decision list construction is typically composed of two main tasks, rule generation and rule selection. FRECLES applies a parametric rule selection approach, and this approach can end up overfitting to training data with small sample sizes, and thus produce excessively long decision lists that can be uninterpretable and unreliable. We propose an algorithmic rule pruning approach for use in building short decision lists and preventing the list from overfitting to training data. Rule pruning is performed using permutation testing prior to rule selection, with the objective of removing rules influenced by sampling variance and that would not generalize well when evaluated on new data. For permutation testing, we estimate the probability that rules are generated from a data set without permutated class labels, and prune rules that do not meet a defined probability threshold. We conduct two experiments. Experiment 1, where the surgical ICU is considered the local unit and the medical ICU is considered the external unit, and Experiment 2, with the local and external unit assignments switched. We then generate decision lists with and without rule pruning, and assess the decision lists on whether the application of the external unit model applied to rule-identified local unit patients improves the area under the receiver operating characteristic curve, or the aaai-uc. We apply each experiment to two data sets, which we refer to as CH and MIMIC2. The results with rule pruning show that 3 out of 4 dataset experiments result in an average increase in aaai-uc with the use of the external unit model applied to rule-identified patients. This is compared to solely applying the local unit model to all patients. In addition, decision lists generated with rule pruning are shorter on average than those generated without rule pruning, and these decision lists are thus more interpretable and reliable. Experiment 2 with the MIMIC2 dataset most effectively demonstrates the utility of rule pruning to obtain the same aaai-uc as that without rule pruning applied, but while using only a third of the rules on average. Future work will focus on accurate and computationally efficient methods for determining the appropriate probability threshold at which to prune rules. I would like to acknowledge support for this research under the following grants. I would also like to acknowledge collaborations with researchers at Carnegie Mellon University, as well as clinicians at the University of Pittsburgh Medical Center. Thank you to the following for their guidance and support throughout this research.